Before we continue with one example, just let us recall the following. If we have a double integral of this form, where the integrand is a product of a pure function in the first integration variable x and a pure function of the other integral variable y, then this integral can be computed in the following simple way. We just take the integral of the function f from a1 to a2 and multiply it with the function of g of y from b1 to b2. So this product, when we compute it, we have the whole integral. Well, let's keep this in mind and continue with an example where we use this formula for the complete solution in the case of a complete solution of the vibrating plate problem in the case when we have a rectangular plate. So what we have to compute here is these coefficients Bmn and Bmn star. This eigenvalue lambda mn, let's recall what it is. It is given by this expression c pi multiplied with this square root. So a and b is the side length of the rectangle. This is the side length in x direction, and b here is the side length in the y direction. So now consider the following example. When the side length in x direction is equal to 4 and in y direction equal to 2, and the tension is 12.5. Don't think about the units, it's not important, let's not be confused by this. And the density is 2.5. G of xy is equal to 0. And what is g? G is the initial velocity, so there is no initial velocity. And the initial deflection f of xy is equal to this expression. So you see here we have a pure function in x multiplied with a pure function in y. This is just to get simple integration. So now we recall that square is the tension T over the density. So it's easy to compute, it's equal to 5. These coefficients Bmn star, they are of course equal to 0 because g is equal to 0, and these coefficients are computed by an integral dependent of g. So the only thing we have to compute is the Bmn coefficients. And we have we know the general expression for this. Let's just go back and see. It's Bmn is 4 over AB, and the integral from 0 to b and integral from 0 to a of this function. Now f of xy is a product function, so it will be much easier to compute this than in the general case. So let's go back now and see how this can be computed. We get, by inserting all values for f of x, we get this expression. So now we see that we have a product of a function in x here and a function in y here. And therefore we can split this integral into two integrals and multiply them with each other. One from 0 to 2 and one from 0 to 4. and this integral is integrated with respect to y, and this is integrated with respect to x. And it's easy to compute this integral by using the same method as we have done before. We use just separation of variables, and I'm not going into details here. We are finding that this integral is computed and by this method, and the result is what we write here. It's 128 divided to m in 3, pi in 3, multiplied with 1 minus 1 in m. And this is the result for the other integral, and we just multiply these values with each other. So then we obtain the following, that Bmn is equal to this for m and n, when m and n is odd numbers, and it's, as we have seen many times before, it's equal to 0 when m and n are even numbers. So by using the general expression for the solution u, we obtain this expression. And this expression is what we note here, that we can drop the 0 terms here when m and n is even numbers. So then we note this, m and n should be odd numbers in this expression. And in order to compute this by Maple or Scientific Workplace or other programs, it's good for us to change the counting variable from m to 2k plus 1, because we are only using odd numbers, and n should be of the form 2t plus 1, where k and t are integer numbers. And we note here that we should start the integration from m equal to 1, and in order to change this to the k and t variable, we have to start summing from the summation from k equal to 0 and t equal to 0, because then m is equal to 1. We sum this up to infinity. So this is one example where we have found the solution.